Hello, everyone. On this occasion, I will explain a little about code quality, readability, and smell. This material has been presented for an international webinar from Universitas Negeri Padang. Okay, I'm Oscar Karnali, Dean of Smart Technology and Engineering from Universitas Kristen Maranatha. So this is a little information about me. So I completed my PhD from the University of Newcastle, Australia in 2022, and I'm currently the Dean of Faculty of Smart Technology and Engineering, and my age index is 11 for Scopus and 18 for Google Scholar. I'm also an associate editor for GCB and Discover Education. My interests are learning technologies and programming education. I published more than 100 articles regarding the topics, and I'm also a reviewer on many journals and conferences. So, we will talk a little about code quality, code readability, smells, etc. And I will try to make it simple so that it is easier to understand. First of all, what is code quality? So, high quality code should have at least four aspects. First of all, it should be readable. So code quality does not necessarily mean code readability. Code readability is one aspect, but for code quality, there are many aspects to be considered. The second one, code quality. Code should be simple or low complexity so that it can be like easier to manage in the end. And also code should have high in-class or in-file cohesion. It depends on the concept that you use. If you use object-oriented, of course, you can say in-class, but if you use procedural, then we can say in-file or in-function, whatever, okay? And then it should also have low interclass or interfile coupling so that when we try to expand, we do not need to check for other files. We can just only focus on one particular file. So there are like several examples of code quality issues. Like first of all is cyclomatic complexity, empty branching statement, inline conditional, overly deep nested looping, and also duplicated code. What are the benefits basically for high quality code? So basically, the first and the most important part is it will make your code easy to read, even by other people. We need to remember that usually, if we work as a programmer, we need to work in teams. And of course, other people need to understand our code. Other people sometimes need to update our code. And other people sometimes need also to expand our code, which means we need to make it clear, make it easier to understand, because if it's like difficult to understand it, it will take a lot of time. Some of you might have experienced that when you read other people's code, it is more difficult than reading your own code. So let's imagine if the code is not readable, it is far more difficult because you do not understand what is the purpose of this code, why this kind of branching exists, whatever. Second thing, of course, if you have high quality code, it will be easy to maintenance. Yeah, because you have like low coupling between files or classes. So if you want to expand, that it is easier for you just to update one class while keeping other classes intact. Or also, if you want to like modify, it is also easier. If you want to remove some parts, it is also easier. The next thing, it is also easy to find issues or bugs. If the code is like big, then you need to search by yourself what kind of things causing this bug. And if your code is like not really well managed and not well documented, then it is difficult for you to find where is the causes. And the next one also, it is easy to expand. Yeah, as you have the code, then if it is like well designed, then it is easier for you to add more components or add more classes there. The next one is code readability. As I said before, that code quality does not necessarily mean code readability. So code readability is one part and code quality is another part. So code quality is covering many things, not only readability, but also about the coupling, the design, etc. So it is basically part of code quality. And what is the purpose of this one? Purpose is the code should be easy to comprehend. Yeah, maybe some of you have already been aware of several simple practices. For example, you need to provide comments for your code. It is necessary for you to explain the code in human language. Why? Because we do not know that in the future, maybe your colleagues read your code, or maybe yourself read your code. Then it is easier if you have human language on there. You need to remember that programming language is initially designed for computers, not us as humans. Of course, I'm aware that some programming language can be like easier to comprehend, for example, Python compared to C++, okay? But still, they are not initially made for human, okay? So it is sometimes easier for you just to add comments, especially if the modules are complex and you need to understand it fast. The next one that can be helpful is clear and meaningful identifier name. Identifier means variable names, class names, functions names. It needs to be clear and declarative. So the name should be not should be long. It should be like clear, but not should be long. So it should be short, concise, but declarative. So when people read the variable names, they understand, oh, this is the purpose. When people read a function name, they will understand, oh, this is what it will do. When people read a parameter name, they will think, oh yeah, I know. This is what the parameter will do. Something like that. And of course, the next one is like methods with adequate length. Because yeah, if you put too much code in one method, then it's like difficult for you to understand and also for other people. And also another issue is like it is difficult to maintain. Okay, that is another part. But of course, the main concern is more about readability because machines do not really care about long code, short code. As long as they can read it, it doesn't problem them. Okay. So that is about code readability. Actually, I have some research relating to this. So I developed a system that can remind students about code readability. But yeah, of course, many of those are like quite common code quality issues, like the ones I display here, like comments, identifier names. But sometimes also when they use like shorthand if, I will try to remind them that it's not really readable. So what is code smell actually? So we learn about code quality, code readability, and now code smell. Basically, code smell is another name for code quality issues. Okay. So we can say it is internal issues in the code. It it does not necessarily to be bugs, but it can be bugs also, yeah. But more about design problem or code problem. So for example, if you try to develop a code and you start to duplicate some parts of the code to other parts, then you need to realize that basically you have code smell because it will be an issue later. So I did the same thing for my PhD. So because my PhD initially designed to be one particular system, and then after that I tried to expand it further and further. So when I try to expand it, some parts of the code needs to be copied to another function. And I noticed that it it became a problem for me in the end because I will have like several duplicated code. And when I try to change one thing, then I need to change another things. Okay. Another issue is like long code. Of course, if you have like too long code in one function or one method, then it is difficult for you to track the code, find issues, to find bugs, something like that. And another thing is temporary field. So sometimes we often use a variable like temp or something, and then yeah, it is not really helpful because of course the names just like temporary or something, not really meaningful. And another issue is like we use another variable just to store existing variables. It is not really efficient also at the end. And also another issue is like irrelevant comment. Some of you might be aware that comments can lie. Okay, comment can lie, but not the code. I think there's a kind of jargon for software developers because when they do a big project, they will see that some comments not really helpful. Some comments just say what it is needed to be a comment. They just say, okay, this function accept these parameters and returns this. That's all. It is not really meaningful. Okay, that's not really meaningful, and that is not really helpful if you want to tweak the code or maybe expand the code. And the next one is, of course, the issue at design level. So if you go for large projects, usually you will need to consider the design. As you might see that if you learn object-oriented programming, usually the problem that they will try to deal is not as small as introductory programming, right? So in here, I'll try to put several common examples of design level issues. The first one is God class. You know the name states. Basically, God class is a class or a file that can do anything. That can do anything, so you do not distribute the responsibility to other files. And without that class, then your program is nothing. That is God class. And another thing is like spaghetti code. Of course, when you try to put everything in your code and you do not think about the design at all, you just think, okay, I need to put this code, I need to add this. That is spaghetti code. So it is like really hard to read, hard to manage. And of course, another thing is cut and paste code. Remember that when you try to cut and paste, basically you are taking other people's code to your own. And your style might be different. So in my case, usually when I search code from GitHub or maybe Stack Overflow, I will take the code and then I will try to incorporate the code to my own. I will try to change the variable name so that it will match my style. I will try also to change the programming syntax so that I am used with the syntax. Because if you have like different style, sometimes it is difficult for you to read or understand the code. So that is code smell. There are many other code smells. Okay, there are many other code smells, and sometimes they are mixed with code quality issues and something like that. But for me, I'm more like they are just definitions. So they can be like everything, they can be anything, up to you. Okay. But the main thing is like we need to know that, yeah, we need to mitigate code smell. We need to deal with code smell so that we can have high quality code. That is in general. And this is the principle that usually people follow when they develop software. It is solid principle. This is basically for object-oriented programming, but for procedural, you can try to consider one class as one file or one function, something like that. Okay, first is single responsibility principle. So every class should have only one responsibility. If you put two or more responsibility, it is likely that they will turn into God class. So they will have many responsibilities, and without that class, you can do nothing. Another thing is like open-close principle. So software entities should be open for extension, but closed for modification. So you have your own code, and then you want to expand your code. If you have solid principle and if your design is good, then it is easy for you to extend. But of course, it is somewhat more challenging to modify because you need to know the class, and sometimes if the class connected to other classes, then you need to understand that kind of thing. But for the extension, it should be easy. If it is difficult for extension, then your code has some kind of issues, some kind of design issues. Might be from code smells. And another thing is like list scope substitution principle. So functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. So when we try to encapsulate something, then we need not to care about the details of the encapsulated file or classes because that is the purpose of encapsulation. So when we try to encapsulate, it is like putting a bag on your code, so you do not need to understand the detail of your code. It is quite common for developing APIs. So you might see that ChatGPT, Facebook, something like that, they have APIs. And then users only need to know how to take or how to use the methods or APIs. That's all. They do not need to understand the behind uh, of the method. So they do not understand, oh, how basically ChatGPT relay messages to their own servers and to generate responses. They do not care. Okay. And then another thing is like interface segregation principle. So clients should not be forced to depend upon interfaces that they do not use. So basically, when you use interfaces, then try to make sure that all of the interfaces are used and are relevant to any classes, any objects that implement those. And last thing is like dependency inversion principle. So we need to depend upon abstractions, not concretes. So it is quite similar with the third one, actually, basically. So when we try to make a software system, then we need to consider the abstraction so that it can be helpful for extension and also, yeah, for the third principle, so that we do not need to understand the details of the derived classes. Sorry, the superclass. Okay, and then one thing to remember is that code quality, code readability, and code smell are sometimes relative, or we can say subjective. Okay, what is readable for senior programmers might not be readable for novices. Okay, you can see that, for example, in Python, senior developers will try to use like list comprehensions. They will use with lambda functions, but those things are not common for novices because they are difficult to read. Another example is like if you try to use maybe shorthand if, so one line if else branching, then it might be readable for senior programmers, but not readable for novices because it is more difficult to understand. Okay. And also another thing, even readability in human language is subjective. What is clear for Vietnamese might not be clear for Japanese, and something like that. That is like this example. So even in human language, we know that when we go to another culture, it can be like difficult to understand. Even the language is the same. Even the language is the same. Yeah, another more obvious example, if you go to Malaysia, then you might find that some of the expressions might not match with Indonesian expressions. And also when you go to Philippines, also some parts is like different. So another thing to remember is like programming shortcuts like inline conditionals, as I mentioned before, are provided for efficiency. So if you are senior software developer or something, you might be encouraged to use that instead of using standard if else. So you need to consider community background and their expectation when you try to develop code. Of course, if you are a student, it is easier for you. Just ask your instructor what kind of your expectation. And of course, I think that each programming language has its own guideline to writing clear code, at least for readability. Okay. And Also, if you learn about design patterns, then you might learn that, okay, some patterns are good, some patterns are bad. Okay. Yeah, the bad patterns are usually informed as anti-pattern. Okay. And if you are in the workplace, then ask your senior for existing guidelines. Because if your code has different follows different guidelines, then it is difficult for you uh, and for your code to be read by others. And remember that in a company, you will work as teams, so you cannot work alone. So ask for existing guidelines, or at least if they do not provide that kind of things, yeah, usually happen for startups, yeah, because usually in startups, we do not really have like good management. So at least you can try to read the code and then try to find out what kind of guideline that they use. Okay. And these are several tips of writing high quality code that I usually inform my students, and yeah, either via the application that I develop or manually. So always add helpful comments and identifier name. So do not think that, okay, this code is easy to read. It doesn't matter what kind of variables that I use. Or you might think that, okay, I won't use this later. It is up to me to use my own variable names because it is just like for short period. Do not think like that. You need to consider that, yeah, you might use that in the future, or your colleagues might use that in the future. So always add helpful comments and identifier names. Another thing is indentation is important. Of course, if you're writing in Python, indentation is automated, okay, because you cannot compile with good with bad indentation. So you need to put indentation. But if you go to maybe older programming languages, maybe like Java, C++, then you need to put indentation at your own risk. Okay. Sometimes you see that, okay, it is easier to make it one line, but you need to consider whether that habit matches with your community. Okay. And then if there is a way to make it clearer without compromising its efficiency, do it. Okay. This might be seem not relevant at some point. Maybe if you are senior developer and you see that, okay, my code is readable enough. Yeah, that might be true for you, but not might be true for junior developers. So I think if you can make it like clearer without compromising its efficiency, then you can make it like that. Of course, if it affects the efficiency, like maybe the complexity becomes from quadratic to cubic, then it doesn't necessary to be clearer. Okay. But so yeah, some example is like, for example, if you do like sorting, you know that quick sort is quite fast and log n time complexity. But when you go to insertion sort, which is clearer, but their complexity is like larger, they will be like quadratic time complexity. Okay. And then the next one is create classes or methods as needed. Of course, I said earlier that good design is necessary, but if you put too much design for your small code, that is also inappropriate. Okay. So you need to think what kind of degree that I need to use this kind of design. Should it be more comprehensive or not? Okay. If it's like for small program, you do not need to make 10 classes of it. Okay. You just need like one or two classes is enough. Okay. And then the next one, if you are confused in comprehending your code, other people probably feel the same. So if you feel that, okay, my code is like difficult to understand, then your colleagues might feel the same. And sometimes worse, because I mentioned earlier that it is more difficult to read other people's code than your own code. And another thing is like if you start duplicating code, then you might remember that your code is not in a good structure, not in a good design. But of course, I'm aware that sometimes we cannot be perfectionists. because sometimes we have like deadline, time constraint, and something like that. So we need to yeah, to put aside our perfectionist, and then yeah, we need to start duplicate our code. That is acceptable at some point. Yeah, that also happened with me for my projects. Some of my projects I also do that because I have limited time to do that. But if you have time, then it is better also for you to refactor your code and make it like clearer. Okay, thank you. That's all for my presentation.